This is Shaik Nayeem. So this is my first lecture on centrifugal pump. This is part 1. So in this lecture we are going to see topics like introduction of pumps, pump classification, then we'll have a centrifugal pump, then classification of centrifugal pump, then applications, centrifugal pump components, working principle, important points, then we'll have advantages and disadvantages, and then finally we'll have a conclusion of the. So first topic on this lecture is introduction of a pump. So pump is a device or mechanical component which will transfer the fluid from one place to another place, or it will transfer the fluid from one level to another level. So these pumps are giving mechanical energy to the fluid. So the fluids are getting energy in the form of velocity, pressure, or potential energy. Then coming to pump classification, pumps are divided into two types. First one is a positive displacement, second one is a dynamic pump. So positive displacement pumps are again divided into two types. First one is a rotary, second one is a reciprocating. Dynamic is again divided into two types. First one is a centrifugal, second one is a axial. Again the rotary and reciprocating pumps are divided into subdivisions. So rotary is divided into single rotor and multi-rotor pumps. Reciprocating is again divided into diaphragm pumps and piston plunger pumps. So in this lecture we are mainly focusing on centrifugal pumps. So centrifugal pumps are the devices or components which converts the mechanical energy which is available at the motor to the energy of the fluid. So the energy available at the fluid having the two forms. One is the potential form, another one is the kinetic energy form. The kinetic energy which is useful to transfer the fluid from one place to another place. The potential energy which is useful for transferring the fluid from the one level to another. So the flow and pressure generated dynamically in the centrifugal pumps because these are rotary type machinery. So the centrifugal pumps are working on the principle of centrifugal force. So because of this one, the flow is happening in the radially outward direction. Then coming to the classification of centrifugal pumps may be classified according to the number of impellers. If single impeller are there, then we call it as a single stage centrifugal pump. If more than one impeller is there, we call it as a multi-stage centrifugal pumps. So the impellers may be closed, semi-closed, or open to the system. Now coming to the applications of centrifugal pumps, centrifugal pumps are used in variety of applications. Almost 70 to 80% of centrifugal pumps are used in industry and domestic applications also. So these centrifugal pumps are used in water supply, irrigation applications, chemical, food and petroleum industries, and in mining also. Then coming to the components of centrifugal pumps, we'll have a components like impeller, casing, suction pipe, footwall and strainer, and then we'll have finally delivery pipe. So these components are shown in the right side figure. So now coming to the another diagram of centrifugal pump, we'll have at the bottom a footwall and a strainer. So this footwall and strainer help to extract the impurities in the liquid. So the liquid present in the sump is extracted by the suction pipe, and then it will be driven to the delivery pipe with the help of impeller. So here we'll have a different heads are there. So capital H will have a total head, then small h in the suffix D we will call it as a delivery head. Similarly we'll have a h suffix s which is called the suction head. So this is the original sectional view of the centrifugal pumps. So in this diagram you can clearly see the different components present in the centrifugal pump. Okay, now we'll see the main components present in the centrifugal pumps. So here we'll have a two main components. So first one we'll call it as a rotating component, in which we will have a impeller and a shaft, and second one will have a stationary components, in which we will have a casing cover and bearings. So now we'll see the rotating components of centrifugal pump. So we already seen that rotating components will have, first one is the impeller, second one is the shaft. So impeller is the main rotating part of the centrifugal pump, so it will provides the acceleration to the fluid. So then we'll have a shaft, which is a component which will supplies the motion to the impeller. So it will also supports the impeller and other rotating components. So in this slide we will have two types of impellers are shown. So first one will have a closed type impeller and the second one will have a open type impeller. In open type impeller we can cleanly see the vanes, but in the closed type impeller it is unable to see the vanes. Coming to the stationary component of centrifugal pumps, we'll have first one is a casing. The main purpose of casing is to convert the kinetic energy into the pressure energy. So we'll have a three types of casings are there. First one will have a volute casing, second one will have a vertex casing, third one will have a circular casing. So volute casings are used when we are going for the higher head, but here the eddy currents are generated. Then we'll have a second one in vertex, eddy currents are reduced in that case. Then we'll have a third one circular. So these circular casings are mainly used for the lower heads. So the volute casing is increases area up to the discharge port. So because of this increasing area, the kinetic energy is going to convert it into the pressure energy. Now we'll see the vertex casing. Yes, a vertex casing is used in the centrifugal pumps to increase the efficiency of the pump. Then we'll have a circular casing. In the circular casing, a stationary diffuser vanes are arranged surrounding to the impeller such that the velocity which is gained by the impeller is going to convert it into pressure energy. So these stationary diffusers are used when we are going for the multi-stage pumps. Now coming to the working principle of centrifugal pump, the first step in the operation of centrifugal pump is the priming. So priming is the operation in which all the components such as suction pipe, casing of the pump and portion of the delivery pipe up to the delivery valve are completely filled with the liquid. It is done because they remove the air occupied in these places. So after done with the priming, now delivery valve is closed. With the help of electrical motor, impeller is going to rotate. So because of this rotation of the impeller, the fluid will gain the centrifugal force. After getting the maximum limit, the delivery valve once again will be opened. So the fluid which is gained a centrifugal force, it will move radially outward direction. Now we need to remember some important points. The pressure at any point in the centrifugal pump is proportional to the square of the angular velocity and the distance of the point from the axis of rotation. That means if the speed of the impeller is high, then the velocity and pressure of the liquid is relatively high. Coming to the advantage and disadvantage of centrifugal pumps. Centrifugal pumps are simple and it will consume very less power, so therefore it is relatively inexpensive, and these centrifugal pumps can be used for the domestic and commercial applications also, and it will have low maintenance cost also, and finally it will have a less weight. Coming to the disadvantage of centrifugal pumps, so these will have a poor suction because at the starting state of centrifugal pump we need to give a priming also, so it will produce a cavitation and it will have a corrosion problems also, so it can't be used for the fluids like mud and waste which will have a high viscosity. Then finally it can't be used for the high speed. Finally, coming to the end of this lecture, we've seen the topics like introduction of a pump, then we seen the classification of pump, and then we seen centrifugal pump and their classification and some of their applications and components of centrifugal pump and its working principle, and finally we seen advantages and disadvantages. Thank you for listening.